Great.
Great.
Joe, let's start with you. What sort of concerns or questions do you have for Rick that you'd like to make sure he covers in his remarks?
Well, in desal, it's always brine disposal. So what kind of opportunities are there for managing the concentrates?
Okay, Eric?
Well, and also the interest to hear about the desal application beyond than just typical, desalination, how that apply to the reuse, about the audience question about the production wastewater, industry process, food and beverage, all kind of very industry reuse application.
And Andy?
Rick, how you doing? On the topic of forward osmosis, obviously interested in knowing a little bit more about what sort of draw solutions would be pertinent to the food and beverage applications for the folks on the line here. And very exciting topic. Look forward to hearing from you.
So Rick, is there anything that you heard in the prior conversation with the panel that you'd like to jump in on or weigh in on? Anything before you get started on your own remarks?
Yeah, well, the panel pitched well to my presentation, which I appreciate the setup. So, a good portion of the presentation is about reuse, in that basically it's the same platform, reverse osmosis, for both desalination and reuse. So I'll talk about in my case studies a couple of reuse projects. And then brine disposal, we touched that well. That's rolled into a value proposition for high efficiency water purification and water reuse. So high efficiency is a high recovery rate, so minimize the brine production before worrying about what to do with it next.
Now, audience, I want to let you know that Rick is in a stressed environment with a less than wonderful pipe, so we're going to see him somewhat out of sync. Rick, don't let that bother you, but I'm just explaining that voice and lips are not working correctly, and it's because of the connection. But that's okay. You're here. The content's great, and the content's coming out of the cloud, so everything should be fine. Let's launch it. Rick, it's your show now, and the rest of us are going to turn our cameras off, and we'll see you in a few minutes.
Okay. Well, it's a real pleasure to be with you all today. My screen's a little slow, so if you hear a delay, it's probably because I'm waiting to receive what you're already seeing. So,
Andy, if you're on the, hang on just a minute, Rick. Andy, if you're on the line, could you sort of cue Rick through and tell him when the slides are visible? We're going to have to work through this, otherwise we'll have a 10-second delay every slide.
Rick, we've gone to your introductory slide.
Okay, I got it. Thank you. So, actually, if go ahead and cue our introductory video. I'll start with that as it's booting up here. This is going to set the context for what we're doing as a business.
Today, over 70% of the production facilities in the U.S. purify their water supplies. The majority use a process called reverse osmosis, or RO, which removes salts and contaminants, producing a stream of pure water. But RO is a 60-year-old process that creates excess waste, consumes too much energy, and does not use water supplies efficiently. Yesterday's technology cannot solve today's problems. Desalitech has the solution. Our reflex RO systems open a new era of water treatment efficiency. Thanks to our patented closed-circuit desalination, or CCD technology, reflex systems maximize the usefulness of water resources, reducing disposal costs by 50 to 75% and energy consumption by 35%. This is driving major operating cost savings and providing a return on investment within months while being environmentally responsible. Smart yet simple. Reflex RO systems perform reliably around the globe. With our partners, we are solving water problems and achieving notable savings across multiple market sectors. Desalitech, leaders of high-efficiency water treatment and reuse.
Okay, I guess I'm back live now.
Yes, you are.
Terrific, thank you. All right, so as the video talked about, the world is running out of water, and in terms of new water resources, it's desalination and reuse that are really the only viable new sources for water. So if you look at the primary consumers of fresh water, the sectors, it's industry, domestic use, and agriculture, for the most part. And of those, in the developed world, like the United States, industry is by far the biggest consumer. 60% of freshwater withdrawals are by industry. That's expected to increase much more rapidly than domestic use is expected to increase. A factor of 5 on industrial consumption. So in looking at how industry treats water, high efficiency water treatment is really a necessary and an inevitable part of the future. That's where Desalitech comes in. Our mission is to become the leading global provider of high efficiency and flexible water purification and water reuse systems. And through this, we will be providing sustainable sources of water supply. This is a curve published by Global Water Intelligence, and it talks about new water technologies and sort of the trajectory of development and that they go through. It's a little cynical, but there's a couple of interesting points on it here. If you focus on the right-hand portion of the curve, which is technologies that have been around for a long time, and I'll attempt to zoom in on one of them here. Again. Here we go. So what you see there is MED, MSF, MVC. Those are thermal technologies like distillation. RO, reverse osmosis, has been around for a long time. These are the technologies, these are the platforms that are purifying water and doing water reuse now in many places around the world. There are countries that are getting the vast majority, if not all, of their drinking water supply from saltwater sources. So I'll zoom back out for a minute and then look at the steep part of the curve. These are essentially emerging technologies, emerging companies. And trying like heck to advance my slide here. Here we go. And so what you see, Desalitech is shown on this as pretty advanced in terms of getting productive. It's due to the number of facilities that we have and how readily adoptable, easily adoptable the process and the products are. But I also want to point out that the other companies shown lower down on the curve there, most of them are in an orange color. And in this chart, what that means is that they're brine concentrator technologies. I'm going to get to in a second why it is that there's so many companies pursuing that. But one thing I'd like to say about it first is that most of these companies started out trying to be desalination and water reuse companies and shifted their business plans eventually. And if you look back further on the curve here, you see a lot of the companies descending from the peak of inflated expectations to the trough of disillusionment, are still trying to be desalination and water reuse technologies. So significant focus here on brine concentration, and what that really means is waste minimization. This is a cost of ownership breakdown for a typical brackish industrial desalination or reuse treatment system of about 370 gallons per minute. And what you see in the center is a typical operation, 75% recovery operation. It means that every 4 gallons of water coming into the system, 1 gallon of it goes out as reject waste, so 25% reject. And so the cost items are capital cost, energy, O&M, and the cost of water. And as you can see, by far the largest cost of ownership over a 10-year life cycle is the cost of water. That's the excess water that you need to bring into the system and then throw away as concentrate. If you can raise recovery from 75% to 95%, as shown in the right-hand column here, you can cut the cost of ownership to these systems in half. So that's why on the previous slide, so many companies were going after brine concentration and waste minimization. It really is the highest cost of ownership component in these types of RO treatment systems. So Desalitech's value proposition then is increased recovery and thereby a reduction in water waste. Our systems also consume less energy. This is especially important in seawater desalination applications, but also in brackish industrial and water reuse applications. Our systems have higher increased uptime. They're more reliable, and they offer a level of flexibility that has not been known in reverse osmosis systems before. And I'll get into explaining why that's the case as I move into the technology here. Take a small step back and talk about what reverse osmosis is. If you put pressure on salt water and press water across a semi-permeable membrane, the salts are held back. If you release that pressure, water will flow back by virtue of the osmotic potential. So reverse osmosis is a pressurized process, but you can't do it in the way shown in the beaker on the left here. On the right is how it's actually applied in practice, and that's with cross flow. So pressure is applied, water permeates through the membrane down in this picture, and then the sweep of feed and concentrate past the membrane surface takes water away, takes salts away, or removes the concentration buildup on the surface. And so this cross flow is essential to make RO membranes work. RO is really the workhorse for water purification. In Abigail's presentation, most of the water reuse schemes that she showed have a reverse osmosis component in them. And that's because if you have to do water purification, you want to do it with reverse osmosis. It's the most affordable and reliable way to go about it. However, modern reverse osmosis hasn't really evolved as a process in the 60 years or so that it's been used. It's really hit a technological plateau until now. So this shows how RO is done in practice. This is a traditional multi-stage reverse osmosis system. You need multiple stages to get to high recovery. But unfortunately, adding stages adds complexity and cost and inflexibility. And if the system gets out of balance, it's subject to fouling, scaling, and reduced recovery. So this is a simple filtration, different kind of filtration. This is actually the most common kind of filtration. And here, a filter takes out the dirt or whatever's in the water, and all the water comes through. So you're operating at 100% recovery. All the water in goes out, and every once in a while, you either flush the membranes or replace them. So the advantage is unlimited recovery. The disadvantage is you can't use this for RO because you don't have the cross flow. Desalitech introduces this breakthrough really in the RO process. And that's we call it reflex RO. And really what it is a combination of the last two technologies shown. There's a high pressure pump that feeds a single stage membrane array. Concentrate is returned to the membrane feed with a circulation pump. And then it continues like this without releasing any of the concentrate and producing the purified water stream. Periodically, the brine valve opens and the salts and concentrate flush from the system. So it operates in two modes, closed circuit with 100% recovery, and then flushing mode, and that's roughly about, the latter is about 10% of the time. With this process, we are able to achieve up to 98% recovery in a single stage. Basically, the longer you allow the concentrate to recirculate, the higher the recovery gets. So that recovery rate is set at the control panel. So you can program the system to release the concentrate whenever, as soon as or as late as you like. And that flexibility in being able to adjust recovery at the control panel is a tremendous advantage from both a design standpoint and from an operation standpoint. The cross flow that you need for RO is done by the circulation pump, and that's adjustable as well. And then finally, fouling and scaling of the membranes, which can be a problem, especially in water reuse applications, is limited by the good cross flow in these systems, and also the cycling of salinity from high to low disrupts biofouling. Okay. Briefly about how this technology came about. It was actually developed by a professor of physical chemistry who had a vision for hydrostatic closed circuit pressurization, depressurization. It's more energy efficient. And then the batch-like operation allows for higher recovery. So those are really the goals. The first patent on this approach was issued in 2008. And then finally, it was only in the last few years that the company moved to the United States, which is actually the biggest market for industrial and brackish water and reuse with reverse osmosis. Our company headquarters is in Boston. Our first food and beverage project was in 2014, and I'll talk about that project and some others here in the next slide. I'm actually going to skip this case study in the interest of time and talk about these. So the one on the left is Mid-American Steel. It's a water reuse project. It was a metals shop manufacturing site with a very dirty cleaning water with circulation loop. We are now recycling that water back into the plant for continued use and dramatically reducing the amount of water that had to be hauled off-site. About a 6-week ROI on that project just based on the reduction in waste generated. The one on the right is a food and beverage plant. Again, by increasing the efficiency with which they were treating the water, raising recovery, and lowering the reject flow, that project enjoyed a less than a 1-year ROI. So here's another project. It's with Coca-Cola. What we're doing here is taking brackish groundwater and taking the salt and minerals out of it and using it for ingredient water in Coca-Cola projects. This is 2 systems you see on the pictures of here. One of them operates at a guaranteed recovery rate of 93%, and the other at 95%. And both of these have been operating since last year. Okay, here's another listing of projects. There are a number of projects in a number of different applications. Draw your attention to the one in the middle on the left. And this system is being used by Los Angeles County Sanitation District. It's a municipal water reuse project operating at very high recovery rates High recovery is essential to minimize the amount of reject. It's difficult to downstream processing of the reject brine can be expensive, so our operation here minimizes the amount of that stream, and then it can be handled efficiently downstream. So Mid-American Steel I talked about, another water reuse project. Hershey's is a wastewater treatment project, also in the food and beverage sector. And wanted to mention that our experience with water reuse has led to us being specified for a project with the City of Los Angeles, another water reuse project like the LA Sanitation District project. So these systems work very well for water reuse, and it's primarily because of the fouling resistance and high recovery rate. All right, so turning to potentially your application and understanding whether it's worth it to implement a Desalitech system. If you can raise recovery on your RO process from 75 to 94% recovery, which is typical, this is typically the value proposition that Desalitech brings, you can enjoy less than a 3-year ROI, even if your cost of water is only $2 per 1,000 gallons. The average cost for commercial water supply and wastewater treatment is about $13 per 1,000 gallons. So even if you're a tiny fraction of the average cost in the U.S., you'll get a less than 3-year ROI with higher recovery RO. So Desalitech's value proposition, again, high recovery also, along with that fouling and scaling resistance. Our systems are built out of standard reverse osmosis components. Our innovation is putting those components together in a new way. And then finally, as a new company, or really as any company in this space, we offer excellent customer service, and that includes being able to remotely monitor and control our systems. So let's work together. The way we go about designing and implementing projects is first, we get your water analysis. So give us an analysis of the composition of your water. With that, we can do a design and cost it out and give you a guaranteed performance on recovery rate and on energy consumption. So we do pilot systems, although generally speaking, it's not necessary to pilot an RO system. They work according to their design, and this is pretty standard across the industry. Nevertheless, we do have pilot systems available. We have a standard product line of RO systems from 10 gallons a minute up to 1,200 gallons a minute. And if you'll check Desalitech's website, you can see a listing of those products and services. And so with that, I'll thank you for your attention and take some questions. I'm horribly frozen.
Hey there, you caught us all unawares because you finished 2 minutes early. Quite a lovely presentation. I want to thank Andy Shea for introducing us to Dr. Stover. That's how we met, and thank you, Rick. So why don't you start, Andy? Why don't you start with questions? Was he as good as you hoped he would be?
Sure thing. I think Rick's been on the cutting edge on a number of technologies, and whether or not it's seawater desalination or industrial reuse. Obviously appreciate his perspective. Rick, you talked a little bit about high recovery systems, and I think we're getting into the area of, if it wasn't zero liquid discharge, it was probably near zero liquid discharge. Are you seeing some of your client base being driven to reducing or eliminating their discharge as being a fundamental driver?
Well, yeah, you're welcome. So, question again? Sorry?
Rick, are you saying zero liquid discharge as being a driver for some of your systems in the marketplace?
Yeah, in some locations, zero liquid discharge is a requirement. Not many, but in those that do, the way that's achieved is that first you operate at high recovery, and then with your brine concentration process, you treat the residual down to a solid. Most of those downstream processes are thermal processes. It means they're very expensive from an energy standpoint and very expensive from a capital standpoint. You need specialty materials. And so in all VLD applications, the goal is to go into the thermal step with as concentrated wastewater as possible. And the best way to do that is with a high recovery RO. We have a VLD process running in India now that does exactly that. So high recovery RO followed by distillation.
Eric, how about you? Have any questions or insights?
Yeah, so Rick, appreciate bringing up to all this. RO is not quite the same RO in the last 20, 50 years. So enjoy your presentation. So as the fresh water side of the wastewater, for example, effluent reuse, definitely I think I'd like to see when the RO is the right opportunity and when RO is not really a good application.
Okay, so the question is, when is RO useful in water reuse applications and when is it? Really what RO does is remove dissolved solids. That's what RO is great at. So if the water has organic materials, suspended solids, biological materials, for example, you really want to remove those with other types of treatment steps. Then if you need to remove dissolved species, RO is the best way to go about it. So at that point, you use RO. And then if you need disinfection or reuse, that's downstream from, you operate on the permeate from the RO, downstream from the RO. So Abigail's presentation did a great job of talking about the different components one needs in an overall treatment scheme. There are many industrial applications where the water is ready for RO. So that's all you need is the RO step. But in others, it's part of an overall solution. In others, you don't need it at all. A lot of agricultural applications, you don't need RO because the water isn't saline. But if it's saline, RO is the way to get it out.
Thank you.
Joe.
Yes. Well, I'm intrigued that you're able to produce this small amount of concentrate at lower cost. So I'm curious, though. You said you use the same RO components. It seems to me if one is recycling the brine, the concentrate, the salts concentration increases. That means the pressure increases. That means the cost increases. So how do you reconcile all of that? What's unique in your process?
Right. So I guess the question is, if you're increasing the salt concentration to a high level, energy consumption becomes more important. When I showed the cost of ownership breakdown for brackish, that's really for the salinity of most water reuse and industrial applications. The salinity is low enough so that the pressure requirement is actually, my estimate is 6% of the total cost of ownership. So in going to higher recovery, you may increase the energy requirement. Even if you double it, it's not nearly as much as what you're paying for the excess water you need and the excess brine you generate while you're operating the system. It's not the case in seawater. I think those that are aware of seawater applications for RO know that about 2/3 of the cost of ownership on seawater RO is energy consumption. So there, increasing recovery is not something you want to do. Typically, you're operating at 45% recovery. So in those cases, in our seawater RO applications, the value that we bring is lower energy consumption, 20 to 35% lower energy consumption for seawater at the same recovery rate in flux.
Okay, thanks.
So great panel. I see that you've been monitoring the audience chat questions. We have about 30 seconds right now to address any questions that you've seen that haven't been asked of Rick. Is there anything that we should ask on behalf of the audience right now?
Actually, I saw that one question on the chat-in asking the RO for the city water 22 gallons per minute. Somehow I cannot read that whole complete sentence right now. Somebody can read that?
Andy, Ron, have you got that? I'm not able to.
Oh, you go.
So you're running.
Here you go. I got it. So question probably to Rick. from an audience say a RO 220 gallon per minute, 22 hours a day of the city water to make a high-grade processed water in the dairy plant. They installed in the RO in 1984. We use 75% recovery. My question it will be, there's still a good payback with your system.
Right. Well, yeah, it looks like, so if we put an RO system in there, pulled that 1984 system out, and that's terrific that it's still operating after 30 years. But yeah, just by raising recovery on that system, if we can get up to 90% recovery, you'll have less than a 1-year payback, just in the amount of water that you won't have to put down the sewer or draw from the tap. That's our best case scenario, is if you're getting your water from the tap and putting the concentrate down the sewer. We base all our economics on that, and typically are getting less than 1-year ROI.
I guess an important question is, are they using dairy liquids recycling, or are they recycling other water that is not loaded with a lot of organics?
Yeah, that's a good question. Yeah, I guess we don't know.
Okay, we're going to have to leave that one hanging because it's time for us to move along. Rick, you did a great job. Thanks so much. And thank you, audience, for your questions, and panel, thanks for the input.